Alrighty, we're going to talk for a minute about friction. Friction is a force that opposes motion. And there are two types of friction. There is static friction, and that's when two things are not moving relative to each other yet. And then there's kinetic friction. And whether it's static or kinetic friction, the formula for friction is always the same. The force of friction is equal to a coefficient times the normal force. Now this thing right here is the coefficient of friction. And since this side is a force and this normal force is a force, this thing right here doesn't have any units. It's just a number, just a ratio. It goes right in front of it. The coefficient of friction tends to be between 0 and 1. Usually it's a fraction. There are some substances for which the coefficient of friction gets larger than 1, but you know, not enough to write home about. You're normally going to see this coefficient of friction be a fractional number. There is a coefficient of friction for the static situation, and there's a coefficient of friction for the kinetic situation. They don't necessarily have to be the same. Some substances are harder to get moving than they are to keep moving. And actually, most of them are. In fact, it's universally true that the static coefficient of friction is always greater than the kinetic for any given thing. So let's just talk about a situation, you know, one of these traditional physics situations. Let's say you're working in a warehouse or you're moving into your new dorm room and you have this big old box and it's sitting on the ground. And let's just say that this thing has a weight of 50 kilograms. That's over 100 pounds. And you are going to try to shove this thing by pushing it that way. And let's just say that you push with a force of 100 newtons, but the box doesn't move. The box stays stationary. Now you say, okay, there's going to be some friction. I want to know how big is the frictional force. So we have to draw a free body diagram. And free body diagram for the box probably has some weight for the box, and that's going to be about 500 newtons of weight. Now, where did I come up with that? Remember, when we did our calculations, we said that you turn mass into weight multiplied by 9.8. That's about 10. So I'm just kind of doing this multiplied by 10. There's going to be a normal force here, and because the box is not going to accelerate up or down, I can conclude that this is also 500 newtons. I got my push that I'm exerting on this box, and we were told that that's 100 newtons, and the box is not moving, so there's got to be some friction, and the frictional force has to be 100 newtons. Okay, the story goes on a little longer. I'm going to draw the same situation over here, and because the box didn't move, I'm going to increase my efforts. And let's just say that the coefficient of static friction is going to be 0.5. Now, how hard do I have to push in order to get the box to move? Well, the free body diagram looks the same, but the numbers are going to change. So there's my dot, and we're going to have my same 500 Newton weight, my same 500 Newton normal force. I'm going to push with some mystery force we're going to find out. And now this is the maximum amount of friction. The friction is actually going to be mu static times the normal force, or 0.5 times 500, and that's going to be 250 newtons. Therefore, if I want to get this box moving, I have to push with at least 250 newtons of force. It's really interesting that the frictional force is controlled by the normal force. It's one of the reasons why when people try to move heavy things, they often lift up on the thing as well as push it sideways. Because when you lift up on it, the normal force can be smaller because you're helping to support the weight. And if the normal force is smaller, friction is smaller. Okay, what about once I get this thing going? Let's say I continue pushing with 250 newtons of force, but now the thing is moving, we're going to have kinetic friction. Now I'm going to push with a force of 250 newtons, but the kinetic coefficient of friction is going to be less than 0.5. Let's say that it's 0.25, half as much. What's going to happen now? Well, free body diagram. 500 Newton weight hasn't changed. 500 Newton normal force because it's compensating for the weight. I've got my known push force of 250 newtons, and now I've got kinetic friction going back this way. And kinetic friction is going to be the kinetic coefficient times the normal force, and that's going to be 0.25 times 500, which is 125 newtons. So I'm pushing 250 forward, there's only 125 backwards. Now we have a situation where the forces are not in balance. I drew this arrow slightly shorter than that arrow. I should probably make this one look even longer. Do that to it. So you can see that this is a larger force than that one. So we're going to have acceleration. And whenever we have acceleration, we need to get out Newton's second law, F net equals m times a. And we're only going to be applying it to the horizontal direction. So the net force is going to be my 250 Newton force forward minus my 125 Newton force backwards. And that's going to equal a 50 kilogram box having an acceleration of a. Well, this is not too bad. This is 125 equals 50a. And so it looks like a is going to be 125 divided by 50. Let's see if it goes in twice, 2.5 times, and I'm going to get an acceleration 2.5 meters per second if I continue pushing with 250 newtons. Whenever you push something like this, like let's say you have a heavy piece of furniture and you're trying to move it across your room, generally you push really hard to get it going. That is to break the very strong bonds of static friction. And then once it starts moving, you reduce the amount you push to whatever kinetic friction is. And that's often substantially less. And I know you've experienced this if you've ever moved something around the house. Okay, so that's the action of friction. You always got to ask yourself whether it's present or not. And once it's present, you can have an equation that you can calculate it as long as you know whether it's kinetic or static friction.